Lesson 5.1, Graphing Cubic Functions. In this lesson, you will learn how to graph a cubic function, how to graph the transformations of cubic functions, and then actually write the cubic function equation from the graph. A cubic function has a standard form, just like quadratics and linear functions. And I'm going to zoom in here. And here is the standard form for our cubic. And if you have a highlighter, I'd probably recommend that you go ahead and highlight that. Notice we have ax squared plus bx, ax to the third plus bx to the second plus cx plus d. Again, a, b, c, and d are just real numbers. For a cubic function, you only need the x to the third term. However, you might also have an x to the second power or an x or a combination of some of these. Next, we're going to look at the graph of the parent function. To graph a cubic, we are simply going to make a table and substitute in some values, -2, -1, 0, 1, and 2. So if I substitute in -2 to the third power, I get -8. If I substitute in -1 to the third power, I get -1, and so forth. 0 to the third power is simply 0, 1 to the third is 1, and 2 to the third is 8. So let's go over to our graph and plot these points. So here is my graph. Let me zoom out just a bit. Let's go plot those points. So I have 0, 0. I had -1, -1, 1, comma 1, 2, comma 8, and -2, comma -8. So the graph looks like this, kind of like a backwards S, if you would. We have what we call 3 reference points. That would be the origin, and that would be the point 1, comma 1, and -1, comma -1. So when we start transforming this function, those are the 3 reference points that we're going to refer to. We also use the origin, 0, 0. We call that our point of symmetry. Okay. Also known as what we call it the turning point. And we're going to use the coordinates h, comma k, as we did with quadratics, only it doesn't represent the center of the circle or the vertex. In this case, it represents the point of symmetry, also known as the turning point, the origin. So turn the page to page 236, and we're going to zoom in on this bottom half of that page about transformations. When we begin transforming that parent function, x to the third power, it's going to look similar to what you're familiar with quadratics, where we take the origin and we transform it. If we transform it left or right, we subtract inside the parentheses. There's our cube on the outside. To transform it, move it up and down, it's that plus k on the outside. And out front we have this a, which actually does what we call a vertical stretch. And we can also have a constant that is inside the parentheses. So let me look at this. So here's a parenthesis, and that cube is on the outside. So we can also have a constant on the inside of that parenthesis right there. And that's going to cause the graph to be more vertically stretched horizontally. And you'll see that when we do some examples. We're going to look at example A here with the function g of x. Notice that it has a factor of 2 out front, which means we're going to have a vertical stretch. It has also been translated 1 unit to the right and down 1 unit. Looking at the graph to the right, we have the original parent function, and then we have that turning point, which has been translated to the right 1 and down 1. To find the other 2 points, they're going to get translated as well, but they're also going to be affected by this factor of 2. So the easiest way to find those points is to substitute into a simple table for x and y, substitute in the coordinates 2, and in this case, the other point is at 0. Substitute them into the original equation, and you get 2 comma 1, and substitute in 0, and you get negative 3, which is actually off of our graph, but we can at least plot the transformation of the first point, which goes over to 2 comma 1, and sketch out the original graph, or the new graph. At the top of page 238, we're going to try another transformation under your turn number 4. To begin with, looking at this function, I can see that my turning point is going to go to the right 3, but it's not going to move up or down any. So let's go ahead and plot that point, take it from the origin, and I'm going to go to the right 3 spots. Now those other 2 points also follow and move to the right 3 points, but that's not where they stay, because they are going to get stretched somehow by this negative 1/2 in front. The easiest way to figure out where those points go is to make a table. So I'm going to put x and y. My x coordinate is going to be 2 and 4. Simply substitute those into the original equation for x, and you will find out that by substituting in x equals 2, we get an output of 1/2, and substituting in 4, we get negative 1/2. So going over to our graph, I'm going to, let's see if this will let me erase. It won't let me erase that, so I'm going to use a little bit different color here. So I'm going to take this point, 2, and it goes up to 1/2, and the other point goes down to negative 1/2. So these are actually the 3 points we're going to use. This is our turning point, so it kind of looks like this, and that goes down, and this end is headed upward. Now we're going to look at how do we write the equation given the graph, and we're going to use the transformation to assist us. And looking at this first example, looking at the turning point, we know what the h and k are for our function. Let me write it over here. It has this possible a out front, and x minus 2 to the 3rd power plus 1. So just by looking at the graph, I can find that turning point, those coordinates, and I can substitute them in to the equation. Now all we have to do is figure out what is this a value. And to do that, we are going to choose a point. I'm going to choose 3 and 4. 3 is going to be my x value, and 4 is going to be my y value. So I simply substitute in 4 for g of x, which is the same thing as y, equals a quantity. Substitute in 3 for x. Simplify all that, and we actually end up with a is equal to 3. So then I have my equation, and I'm going to write it up here. G of x equals, actually it's already written for us over here to the left. So looking at the bottom of page 239, we're going to do example under your turn number 5. And let's see if we can write this equation. Well, first let's begin with finding h and k. So that would be our turning point that goes from 0, 0, and it is down here. So it has gone left 2 and down 2, which gives us an h comma k of negative 2 comma 2. So that gives us g of x, which is just y, equals a x minus a negative 2, so that becomes plus 2, quantity raised to the 3rd power, minus 2. All right, now I need an x and a y. So I'm going to choose this point up here. This is going to be my x, and this is going to be my y. So y goes in on that side, equals a, x is negative 1, so that comes from this x and this y, plus 2, quantity raised to the third power, minus 2. All right, let's begin. I'll just keep that as a 1. Let's simplify inside the parentheses. So negative 1 plus 2 is 1. 1 cubed is just 1. And our last step is to add 2 to both sides. And again, I get a equals 3. So for our final is g of x equals 3, parenthesis, x plus 2 cubed minus 2. So using transformations, we can sketch the graph of a cubic function. We can also, given the graph, look at the transformations and write the equation. We will look at word problems in class.